Welcome, NLP scholars. Online hate speech detection has become an important issue due to the growth of online content, including social media, news comments, Wikipedia, and in-game chat. Recently, the rise in popularity of Korean TV, movies, and music, for example, Squid Game and Parasite, could result in exposure to harmful content and hate speech in Korean. However, the most common language in hate speech research is English, and only limited resources are available in other languages, such as Arabic and Korean. In addition, most datasets are annotated, using a single label classification of particular aspects, even though the subjectivity of hate speech cannot be explained with this scheme. Our research aim is to propose K-MHaS, a Korean multi-label hate speech detection dataset that represents Korean language patterns effectively. Also, it allows overlapping labels, associated with the intersectionality and the subjectivity of hate speech. K-MHaS dataset consists of 109K utterances, from Korean online news comments. We consider a multi-label annotation scheme, in order to deliver fine-grained hate speech categories. Compared with previous studies, this multi-label annotation scheme allows non-exclusive concepts, accounting for the overlapping shades of given categories. Our annotation scheme has two layers. One is a binary classification that classifies hate speech, or not hate speech. The other is a fine-grained classification. For the fine-grained classification, a hate speech class from the binary classification is broken down into 8 classes, associated with the hate speech category. In order to reflect the social and historical context, we select the 8 hate speech classes that include politics, origin, physical, age, gender, religion, race, and profanity. For example, the politics class is chosen due to a significant influence on the style of Korean hate speech. For the annotation process, 5 Korean native speakers were recruited. We introduced an iterative process that enables faster annotation, and the final labels were chosen based on the majority vote. The inter-annotator agreement returns an average Cohen-Kappa score of 0.892. The K-MHaS dataset contains 109,692 news comments, and provides a multi-label classification using 1 to 4 labels. The unlabeled raw data were collected between January 2018 and June 2020. For binary classification, the proportion of the hate speech and not hate speech satisfies data balancing. In the fine-grained label distribution, the religion and race classes are the smallest portions, in both single and multi-label distributions. The religion and race classes are significantly more common in other hate speech datasets. This difference reflects the cultural aspect, that Korea is a highly homogeneous monoculture, with little variation in race and religion distributions. Interestingly, the gender class occurs at almost twice the frequency in a multi-label distribution compared to a single-label distribution. This indicates that gender-based hate speech is used extensively in combined aspects. To understand the lexical aspects, we list the top 5 keywords associated with each fine-grained label. The number in brackets is the token count. Across all classes, one-word tokens are often used in their stem form to modify the meanings of other words. For example, a token from the word denture is used as an offensive reference to the elderly. In addition, one-word tokens can be combined with other neutral words to create a new offensive term. For example, a token from the word dog is used as a prefix, and a token from the word insect is used as a suffix. We evaluate strong baseline experiments on our dataset, using Korean BERT-based language models that include multilingual BERT, co-electra, co-BERT, KR-BERT using the character level tokenizer, and KR-BERT using the sub-character level tokenizer. For conducting our multi-label classification, we propose to use 6 evaluation metrics, which include F1 macro, F1 micro, F1 weighted, exact match, AUC, and Hamming loss. The overall performance for all labels shows that the range of micro F1 scores is between 0.81 and 0.85 with 4 epochs. We observed that all baselines achieve similar performance, whereas multilingual BERT, pre-trained on 104 different languages, present relatively lower performance. The coelectro obtains overall the best, or second best among 6 metrics, although this model has a 7 times smaller parameter size than an average of other models. This indicates the effects of the pre-training data source, considering that the coelectro corpus contains modern slang and buzzwords, while other models generally use Korean Wikipedia. The table shows the breakdown metrics for multi-label classification from 1 to 4 labels. For a single label task, K-MHaS using the character level tokenizer achieved the best performance. For the multi-label classification, K-MHaS using the sub-character level tokenizer obtains overall the best, or second best performance. It uses a sub-character tokenizer that can decompose various Korean characters, so-called Hangul syllables, into sub-characters. Therefore, it provides greater granularity in detecting hate speech words by identifying the sub-characters from different hate speech categories. For example, a new hate speech word, dog, communist bitch, is composed of a token and other 2 words. Using the sub-character level tokenizer, this can be identified for 3 different hate speech categories: profanity, politics, and gender. We propose K-MHaS, a new large-sized dataset for Korean hate speech detection, with a multi-label annotation scheme, which can handle the subjectivity of hate speech, and the intersectionality. We provided extensive baseline experiment results, presenting the usability of a dataset to detect Korean language patterns effectively in hate speech. We hope that this dataset demonstrates a clear insight into Korean hate speech detection.